Yeah, I think you, the structural use of glass really sort of emerged in the mid 1990s, I suppose. So that's probably 30 years ago now. And in many ways, clearly it was a replication of mirroring building elements that had been traditionally used in other materials, for example, wood, steel. So, that was an exploration of how glass might actually substitute for those particular materials given that it has a particular characteristic of being transparent compared to those other materials. It has the strength and the stiffness that makes it very compatible to be a beam or a floor or a structural element beyond it just being considered as a window. But it has particular unique characteristics in terms of its behavior, and those characteristics need to be understood and respected and embraced for it to be considered to be a structural element, such as a beam or a floor or a column. And I suppose really the journey of structural engineering in glass started with that, understanding that from a sort of physical perspective. That it involved a lot of testing, it involved a lot of research over the years to understand its particular nuance relative to other materials, and therefore how it can be more applicable. It clearly has its limits in what it can be used for. It hasn't got any fire rating, for example, so the extent to which it can be used as a building element needs to be quite carefully considered in that light. It's since then we have successfully deployed it, as have many others, in the use of structural elements, including initially as simple things such as glass staircases and glass treads and stairs, and that's kind of how it began. And then it evolved into something slightly more ambitious, and then it started to evolve into buildings themselves. And that's where we are now. It's the challenges remain the same in terms of the materials behavior under certain conditions and certain connections. But yeah, it continues to evolve in that respect. I don't really have a favorite project, but I think that they all informed each other. So, and that's probably, to me, the most important thing, is that one project development led to another project development. We were very fortunate in that we were involved in helping to shape projects for Apple in their retail environments. And to be clear, they didn't have an idea to use glass specifically. I think that was, through architecture, initially with Bohlins, Zawinski, Jackson, and later with Foster & Partners. It was more about using materials very, very well. And they had a number of materials that they were interested in using in their particular retail environments. That was wood, it was stainless steel, and it was glass. And so our role was really to find ways in which we could use glass in the most creative way we can. And that evolved from staircases to building facades to buildings itself, from initial projects, ultimately sort of culminating in their campus project in Cupertino. But good examples of that are Apple's Fifth Avenue Glass Cube, which was, in a way, demonstrable of innovation in itself, in that it was first built in 2006 using what technology we had at the time in terms of the scale of glass and the way we could join glass together at that point in time. Between then and 2011, when we built it again, under a program to refurbish that particular project, it embraced the developments of and the innovations in glass technology that had occurred since 2006, for example, being able to make much larger pieces of glass, being able to integrate and streamline connections in a way that we didn't know in 2006. So and that led to other projects. For example, Zorlu in Istanbul, which explores the way in which you can dematerialize connections in glass and eliminate connections in glass, to the Steve Jobs Theatre, which takes on those early experiments from Turkey and Istanbul to a much larger scale in a project that is a columnless, pure structural glass in building that has to perform in particularly high seismic zones, and therefore the consideration of how that works whilst making it look effortless was part of that whole journey. But not one of those projects could have happened in isolation. They were all a relationship of a 20-year journey to understand where the material could start as a structure before I was even involved in glass structures, right the way to where it is now. It's everything happens because of something that happened before. It's just about how you change that, how you develop that, and how you stretch that understanding that you had prior into the next project. In many ways, the most important thing, or the focus of glass design, is not the material per se, it's the connection of the material. Because in glass, that's particularly complicated in that it is a purely elastic material, and therefore, unlike steel or concrete or wood, there is no indication of its potential failure or its potential condition of being overstressed. It ultimately just is, as far as you're concerned, it's fine until it isn't fine, and then it fails. Concrete cracks, steel bends, wood splinters. You have warning, you have an understanding of its material to the extent that when it's under stress, what that can do. So it's a very, very unique material in that respect, in that we have to clearly assume that we will not know when it's likely to break, and therefore we have to take an extra level of safety or an extra level of consideration into the design of that connection, such that those potential stresses that would lead to failure are not reached. And that means considering the locality of those stresses in much more detail than we would typically do in other materials. So it is very much about what is that local stress, how is that generated, how do you mitigate that local stress, and therefore how does the connection that you design ensure that is mitigated and that is limited, or that is dealt with in a way that not only is predictable, so the load path is predictable, and therefore the stresses are predictable, but also in the event of failure, there is a second or third mechanism, redundancy, that you don't think about in other materials, because you have the opportunity to see that they're under stress, as I've said. So that means that, yes, we started with simple timber-like connections 30 years ago. Connectivity borrowed from the idea of how we join wood, because there's parallels to that with glass. There's glass ultimately is, generally speaking, a laminated material. It normally has more than one layer, a little bit like plywood has more than one layer. And so utilizing that language of layers informed us as how we might start to explore the connectivity of glass. That led to, beyond that, it was bolted connections. Bolted connections, whilst certainly successful in a way, have significant drawbacks in terms of their the local stresses that they incur on glass. So understanding that when you put a hole in glass and then you apply a force into glass through a hole, what that generates in terms of local stress, and therefore going back to that idea of redundancy and failure and all those sort of things, to more novel more novel connections of inserted elements within the glass, which help to mitigate that local stress situation, reduce the need for polluting the external level of glass with a connection, because at the end of the day, we like glass because of its properties, because of its reflectivity, because of its transparency, and the more we start to put connections into it, clearly draws away from those ideas of transparency and simplicity. So it's always there's tension always between, the language of that connection, the performance of those connections from a structural perspective, as well as a narrative and a language relative to the fact that we are designing things in glass for a reason. We want them to be transparent. We don't want them to be full of connections we don't need, or that we can engineer out of the structure itself. So there's that constant consideration about what is the connection, how does it work, do we need it, can we eliminate it, can we simplify it so we don't have the connection for transparency benefit, but also because every connection is a point of weakness in a glass structure. So that's the dance that one plays really with the language of connections in glass. Yeah, I think it's an incredibly diverse material, and we're just at the beginning of exploring what it can do. It's unique in the building fabric that we use in architecture and in engineering, in that it has the strength and the stiffness and the longevity that we can associate with things like stone and to that end, we've used it purely, generally speaking, historically, for its benefits of transferring light. We haven't necessarily embraced its ability to do more things. So I think, to answer your question about what would I advise, certainly its curiosity about what it can do, not to be limited to, it as a structural material or it as a window, or it's to say, well, what do I understand about the material itself, and what could it be used for in any way, right? And that will lead to, and if you're curious about that will lead to something that will borrow from some of the things that have happened so far, but we'll find new ways in which we can utilize the material in more novel ways. And I think that we have to do that. It is a material that has an embodied carbon. It has an energy associated with it. It needs to remain relevant because there is no other material like it in a built environment, and it's something that we need because we need to experience light, we need to experience the inside, outside, and our connectivity with it as human beings. So it's vital for our future as a building material, but it needs to be more. It needs to be explored in how we can use it in different ways, and I see that happening now. But for anybody who was starting out, I would hope that they look at it with a completely naive and fresh set of eyes, and look at it in a way that it hasn't been considered before. It's not. Look at it the way it's been used before. Look at it as a material and what it can do, not what it's done.